welcome to the early birds. We're just getting set up, so grab a coffee, invite a friend, or feel free to ask me a question in this pre-chat whilst folk join. We'll formally kick off the show at 8 PM Pacific time, but for now, feel free to let me know where you're tuning in from and your background with WebML. Hi there, Sai. I see you've got a question about learning TensorFlow. So if you're looking to learn TensorFlow.js, I've got a great course for you that's completely free over on edX. I'll put the details in the live chat in just a second, but essentially, if you just know a little bit of JavaScript, you can go from zero to hero with machine learning. So I'll put that in the live chat for you right now. And welcome to Brazil. Thank you for joining, tuning in at this time. Great to see you here. And yes, I just put the course link in the chat. You can open that up in a new tab. The course is free to take. It's about 15 hours of content to watch. So if you do 2 hours a week, that might take you, around 2 weeks to do. So feel free to check that out and let me know any feedback. Welcome to Palm Beach Gardens, Florida. Nice to have you in the chat. Welcome to the show. How do you find out new events? That's a great question. Basically, if you hit subscribe to this channel and click on the notification bell, you'll be able to get notified whenever we go live over on the TensorFlow channel. And that includes my show, but also other shows that might happen as well. And of course, if you want to know when the TensorFlow.js shows go out, feel free to follow me on LinkedIn or Twitter. The social links are on the right-hand side here on the live stream. Feel free to add me there, and I always post when we're doing new shows. No problems. Welcome to the SF Bay Area, people in my own area. Good to see you all. Thanks for tuning in. I know it's late in the USA today. We're actually hosting this for the first time in an APAC-friendly time, so folk over in Asia can join at a reasonable time for the first time in a while. So we're spreading out the time zones. But yeah, thank you for joining at 8 PM over here. That's great to see. And of course, please let me know what you're all up to. What kinds of companies are you working for? Maybe you're a student, you're studying. Let me know what you're studying. It'd be good to know what people's backgrounds are. And welcome, Drew. We have a previous show and tell guest in the chat there. Nice to see you in the live chat there. Thank you for joining all the way from Korea. And if you've not seen our previous shows, by the way, all of the videos we've done in the past are available on our Made with TensorFlow.js playlist on our YouTube channel here on the TensorFlow channel. So you can check those out afterwards as well. Obviously, we've got many to view there, so feel free to check that out in your own time. They're short, coffee-sized break interviews, about 10 minutes each. So they're quite fun to watch in your spare time. This event, we've got about 5 interviews today, so each one is about 10 to 15 minutes in length. So we're probably looking around just over an hour, and then a few minutes either side for me to kind of give you an intro and outro. And also, traditionally, we always have a Google Hangout at the very end where you can all join and actually talk live with a video chat to meet people from the community, including myself and others who you can ask questions to if you've got any specific questions, and that part is not recorded, so that's all private in the Google Hangout, and we can all join that at the end if you want to. So yes, hope to see you there. And if you do stay to the end, we actually have a signed book giveaway today by author Gantnerboard. He's published a book by O'Reilly called Learning TensorFlow.js. and he's willing to give away a book to some lucky viewer today. So for a chance to win that, do join the hangout at the very end, and we'll select a winner in that hangout. Again, for those of you just joining, feel free to let us know where you're tuning in from today. It's always great to see which parts of the world are here in the live chat with us. This is the first time we've been doing this in the Asia-friendly time zone, so it's always good to see if we've managed to reach some new people that we've not seen before. And we'd love to hear your feedback, of course, as we go along, so do let us know how we're doing in the live chat too. And of course, we love emojis on this channel as well, so please show your love to our presenters today, get those emojis ready, and let them know that you're watching. So I see a question there around graphics cards. What NVIDIA RTX card should you buy to train machine learning? That's a great question. It very much depends on what you're trying to do, of course, and there's no one answer that fits all here. I would basically decide what type of model it is you're trying to train and estimate kind of the size of such a network that you're trying to train there, and then figure out what card you need. Obviously, you want to give yourself some room to grow over the years as well, as things might get larger and such. So I personally would just go for the biggest one I can buy with the most graphics card memory, so I can run some of the newer models like Stable Diffusion and all these kinds of fun things. But of course, it's up to you and what you're actually working on, of course. So that is a very personal question based on what you're doing. Welcome to India. Thanks for joining in the live chat there. Great to see you there. Thank you for joining. Yes, I'll put the link into the chat once again. So as I mentioned to others, we have a brand new TensorFlow.js course, WebML course that goes from 0 to hero. And I'm just going to put that in the chat now. There you go. That's the link to bookmark for after the show. If you're inspired by anything you see today, go ahead and save that link for later. It's completely free. You just need to sign in with your Google account or an email address, and then you'll be able to take the course. Welcome to Peru. Thank you for joining. That's great to see people from all over the world here today, already in the live chat. That's awesome. And you are the early birds. We are at 7:40 right now. We're going to kick off the show at 8 p.m. So this is your chance to ask me any questions you might have about WebML, TensorFlow.js. If you're new to these areas, this is your chance to ask some questions about what you're about to see. And of course, I can answer anything that I'm able to right now live here with you before we kick off the show formally. And I'm doing well, thank you. Thanks for asking. And for those who are just joining, actually, I've just been asking others what type of projects they've been working on recently, maybe what industry you're working in, if you're working at a company, and if you're a student or doing something else, let us know what interests you have as well. It's always good to see what people are up to. And you never know, you might even find someone to hack with if you overlap in the areas. So always good to find interesting folk on this community channel. And yes, thanks for the tips there, Jose. I'll check that out after the show as well. It sounds like an interesting read. Yes, my GitHub account is simply Jason Mays, one word. If you search that username on GitHub, you'll find my GitHub. I haven't been active on there recently, I must admit, but from there you'll see I've been looking at lots of the TensorFlow.js GitHub repositories over the last few years, so it's probably better to follow the TensorFlow.js GitHub for all the updates for the TensorFlow.js stuff. But yes, if you do want to follow me there, I'm Jason Mays, one word, on GitHub. Cool. I see we have 33 people now joining early. That's great to see. I'm sure we're going to get a lot more at the actual hour, so good stuff. Also, welcome to Jen Person in the chat. She is one of our fellow developer relations engineers on the WebML projects here at Google. So in fact, you'll be hearing more from Jen in our next show, which she'll be hosting. So give her a warm welcome, and please also ask her questions in the live chat as well. And yeah, she's tuning in all the way from, so good to have some people from other parts of the States as well. A quick question to those who are tuning in. Have you been to a previous show and tell? I'm curious to know if any of you are regulars. I see one or two names maybe, but I'm curious if anyone else who's seen some of our previous shows before. And yes, Trady, that's a very good question. IoT applications are pretty interesting as well. And fun fact, JavaScript can actually run on Raspberry Pis as well via Node.js. So you can run TensorFlow.js models on a Raspberry Pi if you choose to do so as well, which is pretty cool. So you can keep all your programming in JavaScript if you choose to do so. Also, recently at I/O this year, we announced the launch of the support for Coral Edge TPU devices, supporting the ability to take TF Lite models and push them to a edge device, Coral TPU, to accelerate the performance further. And you can do all of that within Node.js, which is really awesome. Welcome to First Timer Ken, nice to have you here. Thank you for joining the live chat, and hello to Jack and Jeremy as well. Jeremy is also a regular. Thank you for joining again, Jeremy. Great to see you here today. I see we've reached 41, 42 viewers right now, so we're slowly increasing towards our hour's start. So thank you again for everyone for joining in. And do let me know which parts of the world you're tuning in from. It's always good to see who we're reaching in these new times that we're trying out these days. And welcome, Oscar. I see you're new to JavaScript. That's not a problem at all. I think you'll find some of our interviews today very interesting, in fact, because some of them don't even require you to code in JS to make use of some of the models, which is kind of fun to play with and see if it's something you want to go further into. If you do choose to investigate a bit of JavaScript, you can take my course over on X that's completely free to take you from zero to hero in the world of WebML if you find anything interesting today. Welcome, Sean. We're another first timer. This is great to see so many new people joining. Maybe this is because we're offering this at a different time. Oh, I know your father. Okay, awesome. Ah, yes, I think your father said you were going to be joining today. So I do know your father. That is correct. So I'm glad to see you here, and I hope you enjoy the show. If you've got any questions along the way, do give a shout in the live chat. That's one of the beautiful things about having it all live, is that you can actually ask questions along the way and hopefully get some answers. And Sean, what's your background? Maybe you can tell me more about what you're up to these days. Are you a student? Are you working at a company? That kind of stuff. It'd be good to know what industry you're coming from. Welcome to Pennsylvania. Great to have you here. Welcome, Dan. And yes, Oscar, we are using JavaScript to execute machine learning models in the browser at super fast speeds. If you used JavaScript in the 1990s, you might be surprised how far it's come since then, and things are now running very fast. In fact, fun fact, some of our models for pose estimation or body segmentation can run up to 200 frames per second on an NVIDIA 1070 GPU, which is very old generation tech. So that's really impressive stuff, and things are only going to get faster as we release new APIs and web standards. In fact, coming out soon, in the hopefully not too distant future, will be Web GPU, which allows you to get even lower level access to the graphics card which hopefully will allow even further performance gains over what we already have. And for those of you who are new to the show and new to TensorFlow.js, if you go to tensorflow.org/js/models, I believe, you can see some of our pre-made models you can use out of the box in just a few lines of JavaScript, which is really, really awesome because you can get started really fast. We even got code examples on glitch.com. I'll put the link in the chat for you to check out after the show. Welcome to all the new folk. Don't be shy, feel free to introduce yourself, say hello to your fellow community. We're a very friendly community here. Maybe you'll find someone to hack with and all this good stuff. I know a lot of people have made connections here on this show and have gone on to make great things. And of course, if you do make something, be sure to use the hashtag WebML or hashtag MadeWithTFJS over on Twitter or LinkedIn, and that's how we actually find the people to bring onto these shows. So if you make something particularly novel or interesting, you might be on this show in the future. So do let us know what you get up to, and I look forward to seeing what you create. And I'm glad you're excited, Oscar. That's great to see. Love the enthusiasm. And Ken, that's a great question. You're using a Microsoft Surface Book that has an NVIDIA graphics card. Is it best to do development on a desktop machine with a more robust RTX graphics card? It depends what you're doing, Ken. I've managed to train a whole bunch of models on a regular kind of 1070 on my desktop, for example. I've not actually upgraded my graphics card yet, and it does just fine for many things. If you're trying to run some of the state-of-the-art stuff, which is, very computationally expensive to do the training, you might want to upgrade, but it depends what you're trying to do. I think you might get away with a lot of things for smaller models especially, and more common ones, convolutional neural networks, that kind of stuff. You might actually do just fine using your current graphics card. I would try it first before you upgrade, and then decide if you need to upgrade afterwards. Welcome, Marcelo. Welcome to the live chat. Great to have you with us today. Thanks for participating in the chat. And this is a good thing. I do want you all to participate in the chat. This is a community, and I would love you to all make new friends to hack with. And on that note, at the end of the show, I'll be doing a hangout, which is separate to the live stream, that you can join, and we can all actually meet face to face there in a video chat to ask any more personal questions you might have about WebML that you might be shy to ask in this kind of recorded setting. That will not be recorded, and you can kind of ask us anything that's on your mind over there as well. And if you do stick to the end to join that hangout, we actually have a book giveaway today by author Gartner Board. He has published an O'Reilly book called Learning TensorFlow.js, and he's willing to give away a signed copy to one lucky viewer today. So if you want a chance to win that, join our hangout at the very end. I see a question from Ken there. Is it better or more common to develop on Linux versus Windows? Any opinion on using Windows WSL2? So I guess it depends on your preference, but in terms of what is most common, I would say most people are probably using Linux to train all their systems on the back end. However, if you're using TensorFlow.js in the browser, it doesn't actually matter because you're doing everything in the browser. I wouldn't recommend training larger models in the browser though, because it will be computationally expensive. And of course, TensorFlow.js in the web browser is optimized for inference, not training, even though it is possible to do training in the browser. In fact, there's a website called teachablemachine.withgoogle.com, and it allows you to do transfer learning to recognize any object you like in like 30 seconds on a regular laptop. It's really powerful stuff. So for certain things, it can work really well. However, if you're trying to train a CNN from scratch, you might want to just do that in Node.js on the server side and optimize to have a really nice hunky graphics card with all the CUDA acceleration enabled and all that kind of fun stuff to get the most out of that. In fact, fun fact, Node.js and Python are simply wrappers around C++ core if you're running on the server-side environment. So Node.js and Python have exactly the same performance for inference, for example. And if you are having a lot of pre and post processing in your machine learning models, so often if you are new to machine learning, you need to basically take some input, transform it to be acceptable by the model. And that can be a non-trivial task. You might need to normalize the data, resize it, reshape it, that kind of stuff. It might be an intensive task. And if you do all of that in Node, you can actually see a 2x performance boost over Python, which is pretty cool. So if you are looking to do real-time applications that are web-enabled via the server, do consider TensorFlow.js on Node. In fact, fun fact, LinkedIn actually use us for this reason. There's a great case study on our blog that talks about why LinkedIn chose TensorFlow.js to actually execute some of their machine learning. And welcome to Hugo Zanini in live chat there, one of our great contributors and GDEs. That's a Google developer expert for TensorFlow.js and machine learning here at Google. So thank you, Hugo, for joining all the way from Brazil. Another great person to ask your questions to as well. I'll just grab the link for you for our blog that I was just talking about. 1 second. So if anyone's interested in the LinkedIn case study I just mentioned, there is the blog post for you. I put it in the live chat. Go check that out in your spare time after the show. And it's a great thing to see such large companies are now embracing TensorFlow.js as well. Nis, thanks for the question. Is JavaScript as easy as Python? In my personal opinion, yes. In fact, 70% of developers use JavaScript globally. It's the world's most popular language in terms of usage. What you decide is easy is down to the individual, of course. So maybe you prefer Python, that's completely fine. Feel free to use that. But if you do like the JavaScript syntax, then feel free to use that as well. It's very popular and has a lot of support from the community. So we have about 7 minutes to go before we actually kick off. So this is your final chance to invite a friend or ask a few extra questions before we get started. Once we get started, I'll be doing an introduction and then going through our interviews one by one. Of course, there's a chance to ask questions between those as well. But any general questions are probably best to ask now if you want to get anything off your chest at this point. Go for it. Question from Nisfair, do I need to know Java to use JavaScript? No, these languages are not related at all. So Java to JavaScript is like ham to hamster. Ham and hamster are not related in any way, and that's exactly the same as Java and JavaScript. They're two completely different programming languages. This is a common misunderstanding because of a name both containing Java, but they're not related. JavaScript is used in the web browser, and Java is typically used on the server side. So for those of you who've joined recently, feel free to tell us where you're tuning in from and your background with web machine learning or machine learning in general. It'd be great to see what kind of projects you're working on or what industries you're coming from. Feel free to type in the live chat on the right hand side, or if you're on mobile, it might be at the bottom, but feel free to whip that open and let us know who you are. And yes, welcome to Nis from India. Thank you for letting us know where you're coming from. Jaden, have I used Replit to build things with TensorFlow? No, I've not. I have not actually used that myself. Maybe you can tell us more about it in the live chat as to why you might use that. So I see there was a question in the live chat about posting links to personal demos. I believe link sharing is disabled by default on these streams. If you do want to share stuff, we can do that in our hangout after the show, and I'm happy for everyone to share links in our hangout at the end. Cool, we've got 4 minutes to go, so we're going to continue chatting for another 3 minutes or so, and then I'll get prepared for our big kickoff, and I'll see you in a bit. So any final questions? Now is the time. Welcome, Warren. Well, thanks for joining the live stream today. Let us know where you're from. And also welcome to Tektronix. Great to have you here. Welcome, Fabian from SF, California. Great to have you here on the show. Thank you for joining today. Good to see some local folk as well as people from all around the world. So a great mixture of people here today. I hope you enjoy the 5 demos we've got for you. There's going to be some great demos from all over the place, from things that might be good for beginners all the way to people who might be more experienced. So there's something for everyone. Okay, so we're about to kick off the session in just a minute's time. So if you can hear me, come back to your computers, get ready to get stuck into the show. I'm just going to get prepared and I'll see you all in 1 minute. Welcome everyone to the 8th TensorFlow.js show and tell. We've got some shiny new demos for you today, some new announcements, and another O'Reilly TensorFlow.js book giveaway thanks to the author Gartner Board. So if you want a chance to win that book, ask questions throughout the live stream to our wonderful presenters, send your love in the live chat, and of course join our hangout after the show where we'll select a winner. As always, it's great seeing many familiar names in the live chat, so welcome back to the regulars. This community really is very special, so thank you so much for being part of it here on the TensorFlow channel. And of course, for those joining for the first time, smash those subscribe and like buttons so you don't miss future sessions. Now, it's not too late to invite a friend. The number of people using TensorFlow.js has grown exponentially since 2020 when we first started this show. And we've gone from 11,000 weekly downloads to 170,000 weekly downloads. And I would love to see more folk getting to know each other, to help each other out, or find someone to hack with. In fact, if you've got project ideas that you could use TensorFlow.js for, let us know in the comments below so people can find you. Now, for those of you new to the show, I'm Jason Mays, WebML lead here at Google. And remember, this is a live stream, so feel free to ask me questions in the chat, and I'll try and get through as many as I can. Today, we have something for everyone, no matter what your background. But if you're new to TensorFlow.js, consider checking out my brand new edX course that's free to take and will enable you to go from zero to hero in WebML with TensorFlow.js. Even better, no background in machine learning is required to take this course, just a willingness to learn and familiarity with JavaScript, CSS, and HTML. I'll put the link in the live chat shortly and in the description for those joining after. Now, without further ado, today we've got 5 new demos built by folk in the TensorFlow.js community, including some amazing companies who've embraced WebML from all around the world. And it should be noted that many of the presenters are here today live in the chat. So do feel free to ask questions as you watch the show, or cheer them on in the live chat to show your support. We do love those emojis after all. And as always, links to the demos and further reading will be in the description of the YouTube video after the show, so check those out to learn more, and of course to try the demos for yourself. Also, to keep in line with tradition, for those of you who want to continue to nerd out, we'll have a smaller Google Hangout at the very end of the show that's not broadcast live, so you can meet fellow community members to ask questions you might have about TensorFlow.js or WebML in a non-recorded setting. Maybe you've got a project idea that you're looking for someone to hack with. Come join us after to discuss, and of course for a chance to win those books as we spoke about earlier. Okay, so with that, let's get the show started and meet our first presenter. In this interview, we're joined by Brad, who's working on a product that empowers developers to build their own computer vision applications, no matter what their skill set or experience may be. First though, Brad, tell us more about who you are.
Hey, Jason, thanks for having me. If I was to describe myself in one word, it's a hacker. I've basically just been building stuff and putting it online for as long as I can remember. I got my start really in the social gaming sphere. When I was in college, I built a Facebook application that ended up getting over 10 million users, and I dropped out of school and ran that for about a decade. And that really brought me into the augmented reality and computer vision world, where I started working on board game helper apps. So I made an AR Sudoku solver and an AR Boggle solver, and kind of launched those and hoped that they'd inspire other developers to create similar things. And in talking to some of my friends, what I learned was they didn't need inspiration, they really needed tooling. And so that kind of led to a pivot to working on developer tools to help other people create computer vision powered apps.
Wow, that is quite the story. I love it. That's very, very interesting. Now, what exactly is RoboFlow then, and how does that work with WebML and TensorFlow.js?
Yeah, so RoboFlow is a developer tool. Basically, we're trying to help developers give their software the sense of sight. So taking image data and turning that into actual information that you can utilize for cool things. So kind of the key insight of RoboFlow is that the way that humans gather information from the world around us is primarily through our eyes, but that's not really the case for computers yet. And so we're trying to change that and put this into the hands of all developers, not just companies like Google that can spend billions on self-driving cars, but all the fun use cases that you can do to just add vision to your applications as well. So what that means in practice is we build an end-to-end computer vision toolchain. It's everything that you need to do everything from collecting images to annotating them to creating data sets to training a model to then going out and deploying it into the wild and building an app. And we've had over 100,000 people that have built on RoboFlow so far, including giant companies. In fact, over 2/3 of the Fortune 100 have used RoboFlow for something so far, but also thousands and thousands of individual developers and students that are just building cool hackathon projects, in their basements. And in terms of how we use TensorFlow.js, there's kind of 3 ways. It kind of percolates and spiderwebs its way through our entire product. So first, we use it as a model-assisted labeling tool. So once users have trained a model, they can then use that as a jumpstart for improving that model. So they get predictions back from their model. And when they're annotating images, that's their starting point. So instead of starting from scratch and having to draw all the boxes, really you're just correcting your model and teaching it new things. You don't have to teach your model the things that it already knows. It's kind of the philosophy behind that. And then secondly, we use TensorFlow.js to let users preview their models directly in their web browsers, which is really magical. You hit train and the model comes back and you can hit go and you just see it right in your browser running on your webcam. And you can try your model in real time, which I think we'll get a chance to preview here in a second. And then third, we kind of wrap that functionality in a developer SDK, and we let them build their own applications that they can deploy to their users' browsers to create all sorts of really cool things.
Wow, that is truly amazing. And 100,000 users, that's incredible. So you might be our largest user of TensorFlow.js that I've interviewed on the show so far. So congratulations on that. Now, I think it's time to show our viewers how they could potentially use this product. Can we see a demo?
So this is an example of how Cardinal Health is using RoboFlow to improve the backrooms of pharmacies. So they have a division of their company that works with pharmacists where one pharmacist can manage several locations remotely over a video stream. And so this runs in the browser on an iPad. And previously, it was just a video chat between the pharmacist and the technician. And then they used RoboFlow to add on a pill counting feature that helps the pharmacists be augmented by the computer vision model so that they don't have to count from scratch. They can use the model to estimate and then adjust up and down where the model has not gotten an exact count.
Wow, that's really cool. I love how this is solving real world problems in industry as well, which is really great to see. What's next?
Totally. So let's pivot to another industry use case, but maybe a little bit more fun one. And this is how Wizards of the Coast is using RoboFlow to power a feature inside of one of their games. So when the pandemic hit, people had to switch from playing Magic the Gathering in person to online. And so they acquired this app called Spell Table that assists in playing Twitch remotely. And so they added a computer vision feature to their app with RoboFlow that can identify what the card is that's being played. And then the players can hover over the top of it and see the full scale version of that card so that they can read the fine print, even if their video stream isn't high enough resolution.
That's wonderful. I'm sure we've got some Magic the Gathering players in our viewership today as well. So that's awesome there. And I love how that's enhancing the digital experience when you unfortunately remote in these days. You can really bring that to life in a way that's readable and understandable at all. So that's really good to see. Awesome. What's up next?
So now we're going to jump to something even more fun, which is how the viewers and the audience can utilize this right out of the box. So this is a website called RoboFlow Universe that we built as a public space where our users can share their trained models with other users, and then those users can build things with those. So this is an example of a playing card model that one of our users created. And so you can see that on the RoboFlow Universe website, there's over 100,000 data sets and 10,000 pre-trained models that you can view. This is one of those. And then we give you the code for you to implement this directly into your application. So this model finds playing cards. And then if we can flip over to the movie magic, I actually did a YouTube live stream of taking this and building an application on top of this. So I took the output of the model, which told me what the playing cards were, and I created a blackjack strategy app that would find blackjack hands and tell you whether you should hit, stay, double down, or split.
Wow. So this is basically card counting, essentially.
Yeah, something
very,
like
very
that. Maybe don't tell the casinos.
So, I mean, if anyone's watching this, combining this with some AR glasses could be very interesting. So, very cool, very cool. Okay, what's the next demo? I think you got one more for us.
Yeah. So now let's do a quick demo of Label Assist, which I described earlier as how you use your model's output to improve the labeling process and make it so that you can iterate more quickly. So here we've trained a model to identify cars, and then we are adding more images to our data set. So we just invoke the model and turn it on, and then in our browser, TensorFlow.js is giving us a starting point by which to label. And so then you just find where the model made a mistake, and you can teach it new things instead of having to teach it the same things that it already knew all over again.
Very nice. And so are you able to do the transfer learning in the browser of TensorFlow.js then to update the model on the fly, essentially, and then you're using the new version right there in the browser, right? Is that correct?
Yeah, totally. You can use that previous checkpoint for transfer learning. The training for that actually doesn't happen directly in the browser, but it's a human in the loop transfer learning, maybe.
Wow, so it's really amazing to see how many different ways you're able to use RoboFlow for this. And of course, with the labeling side of things, that's super useful to people who are trying to create new models as well. Anyone, anywhere can then start getting a better model to do the labeling in real time as they're labeling, which is really, really incredible. So great work on that. So I guess at this point, why did you use TensorFlow.js as part of your solution?
Yeah, there's actually a ton of reasons that we use TensorFlow.js. I think primarily the first thing that gravitated us towards us was just what a magical user experience it is, being able to just click a button and see a model working on your webcam feed. And that's incredibly difficult to do if you can't run something in a web browser. You can imagine, the opposite user experience of like telling users to get a certain graphics card and then install a whole bunch of drivers and like get their system set up. And it's hours versus seconds. It's just like night and day difference. And using TensorFlow.js creates that aha moment where they can really utilize and understand our product really quickly. But besides that, like there's a whole bunch of business reasons as well. And one of those is cost. By running these models inside the user's browser, we don't have to spin up a whole bunch of GPUs in the cloud. The users are using their own machine's computing power, which also means that the imagery never leaves their computers. And so, we never are seeing the output of their webcam feed when they're using these models in the browser. That saves on bandwidth. It saves us in cost. It improves privacy. It's kind of like a win-win all the way around. And then there's another thing, which is until actually relatively recently, using GPU accelerated models was really hard outside of TensorFlow.js. You had to, have a very specific brand of graphics card. But with TFJS, you can, use whatever your user has, whether they have, whatever brand of graphics card it is, or even if they only have a CPU, it just kind of works. And so that allows us to fulfill our mission of democratizing computer vision and getting this stuff in front of as many developers as we possibly can.
Yeah, but there's a really good answers, and I'm sure, given the scale of your product with hundreds of thousands of users using it, that's saving quite a bit of money per month if you were to use server-side graphics cards to do all those inferences and things like that, right? So,
yeah, I mean, it wouldn't even be possible. And the reason that we can offer so much of our product for free is because we're able to offload that onto the user's machine, and the more users we have, it isn't really costing us a ton more money, and so that doubles as a way that we can get this out in front of hundreds of thousands of people instead of just a few hundreds.
Yeah. And you also mentioned, of course, privacy as well. And given that the medical applications you showed us earlier on with the counting pills and things like this, that, there's obvious reasons for privacy in some of these medical situations too. So I guess there's a win-win there for you guys. So that's really awesome to see. So it seems like it's a great fit. Now, if folk want to try this for themselves, how can they do that?
Yeah, so the first thing to do would be explore RoboFlow Universe. Like I mentioned, there's over 100,000 data sets and over 10,000 pre-trained models for basically every use case that you can imagine there. And all of those models you can actually try in a web browser. That makes a lot more sense for the ones that are detecting whether you have a face mask on or not, or playing cards, than it maybe does for some of the manufacturing use cases. But it should give you a great idea and launch point for starting your own projects. And then secondly, there's a whole bunch of projects on GitHub that go one step beyond that and show you how you can take one of those projects and build something. So we showed earlier the blackjack example. Another example is an app that I actually built last week that helps you parse your drone video. And I trained a model to find solar panels, and then it plots those GPS locations on the map. And so we actually have dozens and dozens of aerial models on RoboFlow Universe already. And so it's not just solar panels that you can plot. You can also find things like swimming pools, or you could use this for search and rescue to find, people who have gotten lost in the woods, or for monitoring forest fires, or any of these use cases. It's kind of like this generic technology, and there's an open source repo that you can get started with.
That's awesome. I'm a big fan of drones myself, so that's definitely very interesting to me. And, I guess one extra question here, where do you see this all going in the future?
I mean, our hope is that computer vision becomes a tool in every developer's tool chest. We've reached 100,000 developers so far, but there are millions and millions of developers out there that haven't tried computer vision yet. And so we make a core product that is free for you to sign up and create your own custom computer vision models that then you can utilize inside of TensorFlow.js. On the technical side of things, right now we support object detection with TFJS, but we're working on semantic segmentation and instance segmentation and classification and some of these other problem types that will let you do even more in your users' web browsers. So stay tuned for that.
Awesome. And just to clarify as well, we were speaking about many of the data sets you've got available and there for people to use. Are they all reusable by anyone, or are some of them come with like licensing restrictions, or how does that work exactly?
Yeah, so our business model is if you're willing to open source your projects, then we give you the product for free. And so most of our users opt into sharing their projects publicly. And we know that's not, feasible for a lot of businesses that think of their data as like a proprietary asset. And so that's where our paid product comes in. It's kind of the GitHub model where, if you need private data, that's what the paid product is for. And if you're willing to open source it, then it's free. And so that's how there's, hundreds of thousands of data sets out there available for people to start with.
Awesome. Well, that's really wonderful work. And of course, for those watching, let us know in the comments below how you might use tools like this to bring your ideas to life in your industry. Thanks, Brad, again for joining the show today. And I look forward to seeing even more TensorFlow.js folk embrace your platform.
Thanks so much for having me, Jason. It was a pleasure.
Wow, what a great set of demos there by Brad. And it's really wonderful to see so many people embracing WebML on RoboFlow with over 10,000 projects powered by TensorFlow.js over there. Now, for those watching, what datasets would you like to see more of? What area or industry are you working in? Do let us know in the comments below. And also remember, if you've got questions for the presenters, feel free to type in the live chat whilst they're here during the rest of the show, or send some emojis to show your love. But now it's time for me to head on to our next presenter. Joining us on the show today, we've got Ryan, who's changing the medical industry by making it more accessible to all with the power of WebML and TensorFlow.js. First though, Ryan, please do tell us more about your background.
Hey Jason, appreciate you having me on. A little background on myself. I'm a product designer by trade. So prior to Include, I designed golf clubs for Nike and TaylorMade and like medical equipment for Ethicon and Stryker. But currently I'm the founder, CEO of Include Health. And what we do is we partner with health systems, PT networks, and orthopedic groups to digitize physical therapy and extend care directly into patients' homes via computer vision and machine learning.
Very cool. So maybe you can tell us a bit more about what you've actually created at Include Health then. What inspired you to make that?
Well, it's interesting because the journey of Include has always been around lowering the barriers of accessing care. We actually got our start after witnessing a man in a wheelchair struggle while exercising. And so like our first product in 2018 was an accessible and digitized strength trainer that we put into physical therapy clinics. However, like we knew that we wanted to go beyond machine and even beyond the clinic. And so that's really when we decided to expand our platform into computer vision and delivering care directly into patients' homes on their own devices.
That's wonderful. Yeah, that's really cool. And obviously in the current times where we've gone through the COVID times, it's been very helpful to do this all remotely as well. So this sounds really exciting. Can we see it in action maybe?
Sure. Yeah, I'm a very visual person. So maybe we just pull up this video and we can talk through it together.
Sounds good.
So as we get into this, what we're really focusing on doing is extending physical therapy beyond the clinic. And so traditionally, it's always you got to go to that clinic and receive that care, and it can be hard to access. And so we want to do that through your own device and through computer vision. So what you're seeing here is real-time feedback that we use MoveNet on to estimate pose estimation and deliver this care in patients' homes. We're a medical device that we can run on any device, fully web-based. And you can see these patients doing different exercises, upper body, lower body, with real-time feedback, counting their reps. We track their range of motion. We gather all that and send it back to the clinician for review to help modify their home exercise plans accordingly.
Very cool. And this is using just a regular webcam, right? No special hardware is required for this.
No hardware, no special software, just front-facing camera and browser.
Perfect. What's this interface we're seeing here then?
Okay, so yeah, on here we're starting with the clinician portal, and this is where they create their customized plans for their patient. So they can scroll through and check the ones they want, search through our large database, and just really make sure they find the right movements for that individual.
Nice. So I guess this is being built up over time, and then you can reuse these with other clinicians over time as well.
Oh yeah. We add about 40 to 50 movements a month into the platform.
Wow, very cool.
And then once they select these here, and we should mention that we offer like functional tests and surveys as well. So it's not just the movement data. We're able to collect all this data on that patient's performance. But then once you have it in here is when you can set the parameters of whether it's rearranging the exercises, setting the specific reps, sets, or then you'll see on here as well as you can go in and you can actually adjust the range of motion targets and maybe drop it from 90 to 70 like you see here. as someone doing their squat, and that'll give them real-time feedback as they're doing it.
Very nice. So but you can adjust it to the patient's needs as they're progressing or maybe not progressing to make it a little easier for them.
Exactly.
Perfect.
Once that plan is saved, we package that up and send it to the patient. They get an email or text saying their plan is ready, and then they can open it up on their own device. Once they click it, they open it up and it pulls up this plan and it gives them an overview of what they're about to do, tells them the different movements. We have male or female animations, tells them how many reps or sets they're going to be doing. And then it runs a quick test to make sure that the model will run. And then we start the experience. So here, we can tell what device they're on. So we give them tips to get set up. And then we show them the MoveNet model in action so they understand how it's advancing, right? For not everybody is really that tech savvy. But then once we get into their exercises, we turn the visuals off of the model, and it's just about them and their movement and their recovery. So we give them an intro here of what exercises they're doing and how many reps, and then we'll walk them through their plan. And it's really as prescribed as we make them face a certain direction, verify they're facing that way, so we can measure the appropriate knee range of motion. Give them tips, and then we have a rep counter that comes in, and as I do my reps, you can see my range of motion gauge fill up in my live readout. We don't give them credit for reps that don't hit a minimum range of motion threshold. They're going to go about halfway through. Right.
Very good.
And then while they're doing this, we log all this data and we send that all to the clinician right afterwards.
Amazing. And this UX is really, really slick. I love it. Very easy and intuitive. And I like that you actually show the MoveNet stuff in action at the beginning, just so they are aware why they need to stand, in the correct positions in front of the camera, that kind of stuff. But then it's all about the user thereafter. That's really nice.
Well, it's really interesting. I mean, we work with a lot of hip replacement, knee replacement patients. I mean, our average patient can be in their 70s. So you think you're delivering, computer vision enabled remote care to 7-year-olds. You got to make it as simple and intuitive as possible.
Yeah, that makes complete sense. So what happens after they've completed their routine?
Yeah, so after they're done with their exercises, all that data is collected and sent directly back to that physical therapist. So this is a report that's auto-generated that breaks down their scores across their surveys and their individual movements. You can see their motion scores, and it logs their range of motion for the key joint for each one of those. And then it flags where you have an issue. Like here on the balance test, I lost my balance, and it tracks that range of motion. And then we also record the video. And so if the PT wants to see that with their own eyes, they can do that and be able to really understand what's going on from a movement side with that patient without physically being with them.
Yeah, but so nice to have.
Yeah, absolutely. Right. And then here is where we load up on the trend side of things. So we can see, is this patient being adherent to their home exercise plan? Are they being engaged? And then we can go and look at their individual scores across different range of motion surveys, that type of thing, to just really understand what's going on outside the clinic and just get that patient as healthy as possible. And then directly in here, you can just go in, edit that plan, and keep modifying their care accordingly.
Now, leading into the next question, Ben, you mentioned you used the MoveNet model for pose estimation in this particular use case. Can you tell us more about your experience with using that?
Sure. We dove into computer vision very early on, in about March of 20 when lockdown started. And at that time, 2D pose estimation was still in its infancy. And it wasn't quite ready to be a clinical tool. But we had some pretty interesting use cases with our health systems and also working with the Air Force that actually, Jason, I reached out to you and said, hey, this is what we're trying to do, and didn't know if there'd be an opportunity to collaborate at all. And fortunately we did, and you guys were willing to work together to really just understand where were some of the ways we could teach the model to get a little bit more accurate, to be able to deliver physical therapy to the accurate level. So we worked together for over a year, and I know we were in the IO conference in May of 21, and really it was that collaboration that really made it possible to unlock this platform.
Certainly, and I definitely remember this very well. And I remember the original model that we had for MoveNet. It worked very fast, was pretty accurate, but some of the more extreme poses patients were getting into were not being picked up quite correctly. So with your extra training data and advice, we're able to perfect that. And now we've got a model that, of course, is much more robust than ever before for these kind of medical situations, which is great to see. And of course, all of our users now benefit from that as well. So thank you so much for partnering with us on that one.
Likewise.
Now, I'm sure if anyone's like me right now, they really want to go try this out for themselves. Do they need to be in physiotherapy to try this, or can they actually go and have a go right now?
So right now, we don't offer direct access. We do go through physical therapists. That being said, we want to be able to offer a demo so people can understand the experience. Right now, you can go to our site, includehealth.com, and you can request a demo that we can provide. Hopefully soon we're going to put one, just an interactive one where you could do an exercise or two on your own just to get a feel for it.
Nice. That's awesome. I think that'd be nice just for people to learn how it works, and it's usable for them. If they do ever need that kind of stuff in the future, they can get a feel for it ahead of time, which is always good to do. So amazing. So what's next in your opinion? How do you see this evolving over time? Are there maybe any other machine learning models you're looking to integrate in the future to make this even better?
We are at the tip of the iceberg. There's a lot in front of us. We're deployed with health systems and PT networks and the clinics kind of across the country. We're continuing work with the government, both the Air Force and the VA. Really, it's extending care to people that can't currently access it, right? But even from a technology standpoint, we're really interested in how we can extract 3D data from 2D video and how you can augment your movement data set with that. There's also a lot of interest in being able to perform performance metrics from this. So not just like range of motion, but can you extract velocity, force, power, and look at that across these different joints and really understand what's going on through the movement. So a lot of exciting opportunities to expand.
That sounds really cool, and I look forward to seeing what you create there. Now, as mentioned, links will be in the description after the show, so do check out this great work and consider leaving a comment if you're also working in this space. Thanks, Ryan, for being on the show, and I look forward to seeing more of your work in the future.
Awesome. Thanks, Jason. Really appreciate it.
Thank you so much, Ryan, for that great presentation. I've seen a whole bunch of folk embrace WebML for healthcare, and I'm sure this will continue to grow given the strong privacy aspects of running in the browser. Now, I'm curious if any of our viewers today have a medical background. Please do let us know in the comments and what you might use ML for in this use case. Now, I believe Ryan is live with us in the chat too, so if you've got questions, ask over there, or if you're joining us after, drop a comment under the video. Now it's time to head on to our next demo. Joining us today, we have Bryan, who's been hard at work creating some amazing real-time face motion capture software powered by WebML and TensorFlow.js. First though, Bryan, tell us more about your background.
Thank you, Jason. I'm Bryan. I've got an electrical engineering background, and in grad school, I sort of got into mobile app development and started a mobile app development company where we did a lot of edge-style compute. And that's kind of where I first got my taste of machine learning. And then once I got that bug, I just kept on working on weekend and side projects until finally got to this point right now.
Awesome, love it. And what exactly is Hallway?
Fundamentally, what we're trying to do is build tools to allow anybody to be their true self. There's a lot of people that feel uncomfortable on camera. And actually, we started Hallway when COVID happened and this great office culture that we had with those collaborative just died, and it just became this dead sea of gray tiles on Zoom. Nobody had their video on, and we're like, how do we get our culture back? How do we get collaboration back? And one of the ideas we came up with was like avatars. How do you have presence with privacy? How do you allow people to show the certain aspects of themselves through with an avatar while remaining certain things private? And that was the first prototype, and it's sort of like jetted off from there. Our ultimate goal is to allow people to be as expressive and creative as they possibly can be with a digital avatar.
So that sounds really interesting. Maybe you can switch to a demo and see it in action and maybe go deeper.
Absolutely. So what you're seeing here is the Hallway Web SDK running on our website with Mystery. My face is driving it through the webcam. And we wrote this special piece of software to bridge the facial controls into this little Electron app that then relays those controls into Unreal Engine so you can see the effect of the face tracking.
I love it. That's really, really nice. So yeah, maybe we can dive into how this is being controlled by your face a little bit more. That sounds very cool.
Yeah, and here's like a much more detailed side-by-side view of my face being captured alongside the face of the 3D character. And so what's happening is it's tracking individual facial blend shapes and then relaying them back into that Unreal Engine to render them.
I see. Now, you mentioned the word blend shapes there. I mean, we've got a lot of followers who are maybe new to this area. So on a high level, what are they and why are they needed to make this all work?
Yeah, absolutely. So Blend shapes are a standard way to describe human emotion in faces. It's developed by Disney back in the 50s. It was originally called FACS, Facial Action Coding System. And it's just all the muscles that, your cheek twitches or your eye squints, and the intensities associated with them. And so as fast forward today, every 3D animator from 3D Studio Max, Blender, or Maya, they use the same format to bring their characters to life. Even Pixar movies, they're using the FACS standard. So if you have a machine learning model that can translate the human emotions into FACS, you can drive almost any 3D model using blend shapes.
I see. Interesting. So essentially, you're using face mesh to get the key points of the face. I mean, you've trained another model to take that input data, if you will, to predict blend shapes, which then drive the character animation that we're seeing right here. Very, very cool. Very amazing work there. And, I've got to say, the realism of this is super interesting. Like, it looks, I didn't think it'd be this good. And I'd love to know if we can do this on the web as well. This is running in Unity and Unreal Engine maybe, but do you think it's possible to port this to the web in this kind of level of detail as well?
Absolutely. In fact, there's a demo I just saw recently that in 3JS that has a hyper-realistic human face. So that's possible. You just need to find an artist to bring it to life.
Great.
And then there's like a prototype that I saw that Unreal Engine was running in the web. And
that is true. They can do that now. Yep.
that would be the merge.
Perfect. Nice. And so yeah, if there are any character animators or creators out there watching as well, if you've got a nice character already kind of set up, maybe we could try that with this amazing work and bring it to life in a short amount of time.
Yeah, no, that would be cool. I'd love to work with any type of 3D artist that has characters that they want to bring to life on the web.
Perfect. Now, TensorFlow.js itself does not have, a pre-made model for blend shapes. So how did you go about making your custom model itself?
Yeah, so the custom model is a lot of research to try and figure out like what are FACS, how are 3D models made. And at a high level, it's a combination of blaze face, just for facial landmark tracking, and then after that, blend shapes. So we use Keras to do all of our training, and then we export to TFJS, and that's how it runs in the web.
Yeah. And actually, on that point, a fun fact for anyone watching, if you are trying to run multiple models in the browser, you can actually use tf.setBackend in JavaScript to force it to run with a WebAssembly context or a Web GPU or WebGL context, for example, so you can actually distribute the loads over different pieces of hardware. So if anyone's trying to do similar things, that's how you can get around that as well today. Awesome. Now, I've got to ask at this point, how can people try this out themselves? This is a super cool project. And I think I might have to join my next Google Meet in this form even. So how can we do that?
Yeah, I hope you do. And then if you're interested, I'll make you a custom avatar.
Love it. Yes, please do.
So, you can go to joinhallway.com, and then in one of the tabs there's a demo, and you can play with this right now on the web.
Awesome. That sounds great. We'll put the links in the description after the show, of course. And thank you so much for being on the show. I really look forward to seeing this evolve. And for all of our viewers out there, let us know in the comments how you get on if you try it out.
Thank you, Jason. It's been a pleasure being here. And then also all the viewers, if you have feedback, questions, or want to get access to the tech, just reach out and we'll be happy to help you out.
Cool. Thank you, Bryan. Thank you so much to Bryan for that super creative piece. Just a few shows ago, we had Richard Yee from the VTuber community demo some amazing work for full body animation, but Bryan has really taken this to the next level for facial animation. Really great stuff. In fact, have any of you joined a video chat as a character before? If not, try out Hallway after the show and give it a go. It's a lot of fun. Alright, let's see who's up next. Today we're joined by Alex, who's making machine learning easy to use for everyone. And of course, he's using TensorFlow.js to do just that. First though, Alex, tell us more about your background and who you are.
Sure, Jason. Thanks for having me. Well, I'm a senior systems architect based in Australia. I've worked in R&D and systems architecture for about 18 years now. But my journey with ML just started over a year ago, so I am by no means an expert in ML. I will say that I was actually a bit terrified at the beginning because I didn't really know much about it.
It can be very daunting at the beginning.
Yes, exactly. So I started working with TensorFlow.js because we wanted to add machine learning support to the web platform that we're working with. And TensorFlow just gave us everything we were looking for.
Awesome. That's great to hear. And what exactly did you create?
Well, we created a platform called Kemu. So Kemu is a visual workflow engine that allows you to build very complex solutions in just minutes. And we do that through a drag and drop interface, which helps you define any kind of process without the need for coding. And by that, I mean, you can do things, as simple as, orchestrating classic event-based workflows. So for example, you have a system A that generates an event, and you use Kemu to, call an API and trigger some other process in system B. And also we can do more complex implementations, including machine vision, machine learning through TensorFlow.js. So we basically wanted to build a product for, prototyping, automation, and orchestration of different resources that anyone could use, not only developers.
That sounds pretty cool. I really want to see if it's in action. Do you have a demo for us today?
Sure. So in this first example, this is actually one of my favorites because it combines hardware and software. So what we are basically doing is using an image classifier to control an IoT device. And this is something our users can build in less than 5 minutes. So the way how it works, we have these applications we call things, and one of them is a webcam, which captures the live feed from your webcam. And we send that to an image classifier, which contains the ML model. So if we go inside of the webcam thing, here is where we can fine-tune the logic. In this case, we're not really doing much, but we're basically just sending every single frame coming out of the webcam into our model. But here you could, for example, apply image filters if you needed to before we pass that to the model. The training is super simple. We basically just define the classes we want. In this case, we want 3 classes: one for me, making the post to turn the light on, one for the light off, and one just for me doing nothing. And you just have to click on one button to capture the current frame and add that frame to the class. So we're basically training the model on the spot. And of course, you can later check which images are part of the class, or remove them, or add more. So after this is done, the next time the model sees an image, it will try to guess to which of those classes that image belongs to, and it will generate an event. And with that, we can trigger other things. So here we are just, once the event is generated, we are just waiting a little bit to make sure that class is recognized multiple times. I'm just making sure I keep that pose for a couple of seconds. And then we just send a message to our IoT platform. So one of the advantages of Kemu is that you can create your own widgets, right? So here, for example, widgets, by the way, are those little tiles you see here that we are using to define our logic with. And you can, of course, use JavaScript code as well if you wanted to. So in our case, we are just using a WebSocket connection to instruct our light to turn on and off.
Very cool. I like that a lot. And I love how easy it is to kind of then interact with hardware devices like maybe a Raspberry Pi or something like this, right? So
exactly,
just WebSockets are pretty simple with something like socket.io or something like that. And you can just send data very, very fast, bidirectional. And yeah, that's really cool. I love it.
Absolutely.
And what I've said this before on the show as well to other people who have made some hardware. I always love to see people creating more stuff with JavaScript and hardware. People forget they can do that just by streaming the data over and then classifying things and then sending some commands back and all that kind of thing. So very excited to see what your users get up to with that later on, definitely.
Yeah, that's absolutely right.
Cool. And what else have you got for us?
Well, in this example, this one is very interesting because here we combine 2 very different machine learning models that were trained in 2 completely different tasks, and we put them together to also, achieve something completely different. So in this case, we are controlling a video game with my eyes, and here I'm raising my hands just to show you that I'm not really controlling the car in any way using the keyboard. But if we go inside of the webcam, you can see the logic. So it goes left to right, top to bottom. And what we are doing here is basically we first, as before, we captured the feed from the webcam. and we pass that to the face tracking section, which are those blue widgets you see here. We are running a media pipe face detection model. So the idea is to extract my face and some of the features from my face. In this case, we are trying to cut out the area around my right eye. And what we do then is just pass that image to a custom machine learning model that we actually trained with Kemu using TensorFlow.js to predict the direction in which my eye is looking. Right. Just as a side note, I think the new version of this media pipe model already comes with iris detection. So potentially we can skip this stage once we upgrade our version of the model.
Actually, I've got a question for you at this point. So I like this node flow once again, very nice and easy to use. If you've got some arbitrary model, maybe somewhere on some website somewhere that's built in TensorFlow.js, like the one that you trained here, can you pull that in very easily for if other people got models they want to use into your system?
Not at the moment, but
okay,
that is part of our roadmap, definitely. Yeah.
That'd be very useful if I've got like a custom model I want to then attach to that output there or something. That could be very nice to use.
Absolutely. At the beginning, we were trying to build the platform so that people could train and build the models within the platform, but we realized that most of our users would actually want to use models already built for them.
Sure.
So we're actually trying to implement that at the moment.
Nice. Perfect. Okay.
Yeah.
Good stuff.
So just to finalize with this, we're doing after the custom model evaluates my eye and predicts the direction in which we are looking. It gives us a value from 0 to 100. And you can see here that if I look towards the right, the value increases to close to 100. If I'm looking towards the left, the value goes close to 0. And we're going to use this to control the steering of the car, right? But because our 3D game only understands values from -1 to +1, minus that 1 being, turning the steering wheel to the left, +1 to the right, we use another widget that maps that output from 0 to 100 into the range that we need. And that's pretty much it. The logic actually looks more complex than it really is. But some of those widgets there are just, to give us a preview of the different stages of the process.
Really cool. I love it. And, this could be very interesting for even playing computer games. Maybe if you are unable to move other body parts, if you're, unable to do so, it gives people a chance to actually play games and do other things as well in this kind of action. So that's really awesome to see. Great. Right, yeah. I think you got some other demos for us as well, maybe.
Yes, we have a final one. Just to give you a quick background about this one. So this one is a prototype we put together for one of our users, which runs a restaurant. And they wanted to see if they could use machine vision to track the quantity left of food in different food containers. So this is just a prototype that measures the amount of liquid in that orange container. You see that in the video. And this was a very deliberate setup because in the case of our customer, they wanted to use existing security cameras already in place. And in such scenarios, your target container wouldn't necessarily be, centered and in focused. So that's why we created this video in this way. So this is the final video, the final version of the program. The video is a bit sped up, so things happen fast, but you can see that as water is taken out from the container, the graph reflects the changes in the level of the liquid, which is what we wanted. We built this demo probably in 20 minutes, and it has a few stages. So what we are doing here is we first crop the video to focus on the area that we are really interested in. Because we wanted to use machine vision to count the number of pixels in the vertical axis, we used another widget to kind of rotate the image and make sure the water level was as horizontal as possible. And here is the interesting part. We trained a custom machine learning model using TensorFlow.js, and we're doing a binary classification task. Again, this is something you can do within Kemu. But what we are doing with this model is detecting if my hand is in frame. And the objective with this model is to get rid of those images that had my hand there. You hear that as my hand comes into frame, the video feed in the next display widget basically stops and waits until my hand kind of goes out of frame. After this, we just do a bit of image manipulation. We just trying to look for pixels that are orange in color and marking those in white, and the rest of the pixels that don't fit that description, we just mark them in black. So in that way, we are just basically getting rid of all that information that we don't really need. And finally, we just draw a bounding box, around those white pixels, and we extract the height of that bounding box to represent the water level that is basically what we're measuring here. You can see how important that little hand detection model is, because if we bypass that step, our graph goes a bit crazy. And that's because as I'm taking water out of the container, the liquid bounces around a bit. And those perturbations in the water are also being captured and registered in the graph. So it gives us those very ugly spikes that don't really represent the real level of the water. So that ML model there is making a huge difference for us.
Very interesting. Now, what I like about this is that, you've broken the problem down into many different parts. There's a bit of computer vision going on. There's the machine learning models being chained together and all this kind of stuff, right? So I feel like this could almost be an opportunity to kind of almost get people to challenge each other to make optimal kind of flows of these things, just like they do on Kaggle. But this system would allow anyone, no matter what their background, to actually have a chance of making something really powerful, right? So maybe you want to use a segmentation model for the water and then do something a little bit more advanced. It might be a little bit slower, but you can kind of compare results and see which one is accurate for different video types and make some competition. So I think there's a lot of potential here to make it into a really cool system for people to use. So I'm excited to see what you do there. Definitely.
Yep.
So I guess this is really incredible work, and I love how easy it is to use Kemu and bring an idea to life. But what were your biggest challenges in making this system, and how did you land this final user experience that you've created?
Well, challenges a few. In particular, making sure the ML part fits seamlessly with the rest of the platform. So understanding the basics of ML was also a personal challenge that took a few weeks. Regarding the user experience, I'll say that many years ago, I worked with a 3D engine that used visual programming for the logic. So since then, I've been fascinated with graphic programming. So I took up a lot of inspiration from that. But in line with what you just said as well, I'm a firm believer that making technology in general available to everyone is very important. And coding is still a very scary thing for many people. So I think these type of platforms make our industry a lot more inclusive. So when we decided to build this, we tried to make it as friendly as possible without necessarily limiting the kind of things you could do with the platform. And the result is what you see here today.
Totally. And I completely agree with that. I've had a lot of creative folk on the show in the past, and people I've spoken to at events and things as well. And they've got a lot of great ideas, but they might not be as strong programmer as most of the viewers on the TensorFlow channel, let's say. So it's great to see those people actually bring their ideas to life as well, because often they're really out there ideas that we've never seen before, and they're now able to create these things too. So I hope we see more of that in the future with tools like you've created.
Right.
Now, how can people try this out for themselves? I'm sure many people watching are very keen to give this a go.
Sure. Well, they can go to our website, Kemu.io, and apply to get access to our public beta. So chances are they're going to get a link to access the platform.
Nice. And what type of time frame are we using for people tuning in the future or the past, depending when this airs? Yeah.
Well, we're expecting to go to public beta early next year. But if you watch this video and want to apply, go ahead. As I said, chances are you're going to get access to the platform.
Perfect. All right, awesome. And I've got to ask at this point, I guess, what are your plans for the future? Is there anything that maybe the people watching could help you guys with, and make it even a better product than it is?
Yes. Well, as part of our roadmap, we are working hard on finishing our cloud offering. So right now, everything you just saw is happening in the browser. But there are many use cases in which you would want your programs to run in the cloud, right? So we're working hard to get that part ready. We are also looking for a lot of feedback, especially from enterprise customers. So if you are a company out there and you think you could use this platform and would like to work with us, please do reach out. But also, I guess I would like to invite everyone in general interested in using this platform to go to the website and request access. You mentioned at the beginning about IoT and electronics. I have a background in electronics, so I've been a maker of my life, and I would love to see to hear from others how they would want to use this platform. So go register and tell us what you would like to see and how you would like to use the platform.
Excellent. And of course, we're going to put all the links in the description after the show. And I think this could be really important in like education as well. You can imagine like universities teaching, or even high schools, it'd be easy enough for students to use too. So that could be very interesting to see that develop.
Absolutely.
So thank you so much, Alex, for joining us today. And of course, for all the viewers watching, let us know what you think about Kemu in the comments. And of course, I'll see you next time.
Thanks, Jason. Thank you, everyone. Bye.
Wow, that was some super powerful stuff right there. Thank you, Alex, for helping more people than ever before take their first steps with ML to bring their creative ideas to life. Now, for those watching, if you managed to get on their beta, do follow up on the comments down below on how you found it. Now, I saw a quick question there from Ken about running multiple models in the browser. It's totally possible. I believe Kemu would support that. I would have to check with the founder. But theoretically, yes, you can run multiple models. In fact, we've had many demos in the past on this channel do exactly that. And you can choose to run one model on the graphics card and another one on the CPU to kind of spread the load across the hardware. So it's all totally possible. So it just depends on what device you have, how much you want to push it, but all can be done. Now, if you've got questions about what you just saw, do leave a message. And remember, if you're enjoying the show so far, hit those like and subscribe buttons to be notified of future shows. We do this every 3 months, roughly. Okay, onward to go on to our next presenter. So I'd like to welcome Kevin to the show, who's used TensorFlow.js with a product named HarperDB. Now, before we learn more about that, please do introduce yourself and tell us more about who you are.
Hi, Jason. Thank you for inviting me on the show. My name is Kevin. I'm an engineer with HarperDB. I've been using TensorFlow for about 4 years now, mostly in Python originally, and then moved over to TensorFlow.js. Built a few apps with it, including one that was a bird sound identifier, which worked really well with TensorFlow.js because it could package in seamlessly to the rest of the code base and deploy across platforms. For the past year, I've been working with HarperDB to deploy machine learning models onto their ecosystem and to build POCs for clients. Mostly based around recommendation systems.
Very cool. Thank you so much for being on the show. And first off, what exactly is HarperDB and how does it use machine learning?
So HarperDB is a database package that runs on Node.js. We have clustering capabilities, so you can have multiple nodes and control table level replication between those nodes. So you can control which data flows from one node to the other, and you can store virtually any type of data on these tables. Ranging from binary files with model weights to images or arrays of user interactions. We also have a custom function server that runs alongside the database to where developers can code custom endpoints and control the shape of the data either on the way in or on the way out. So we've been using TensorFlow to build models and run on those custom function endpoints. And then we've been using TensorFlow.js specifically, that way we can code in one database node and have it automatically replicate to child nodes to run closer to the edge and closer to the end user.
Wow, that sounds pretty awesome. I think at this point, it's probably time for a demo to see this in action. What can you show us?
So today we have a POC that we built for a grocery store. It's a recommendation system that is on a hub and spoke topology to where we have 6 different nodes. There's a central node that we will use to deploy the model to, and then it will automatically go back down to the 5 child nodes, the 5 spoke nodes, whenever we add that model to the table.
A quick question at this point. What exactly is a node?
So node is just an instance of the database that is clustered with the other nodes, and you can control per table how the information is moved from one node to the other node, kind of hub sub type functionality.
Very cool. Okay, let's continue.
And you can see here we have the TFJS dashboard. That'll be our central node that we'll see for this UI in just a moment. And then we have nodes 1 through 5, which are the spoke nodes that would be running at the grocery store, where they're going to pull down the model and then retrain it on local data.
Okay, very cool.
So here we're looking at our data viewer. This is just an example of the data that we're using to train this model. This is from a grocery store data set from 2014, 2015. And here we have items that were purchased by user by date. So we aggregated them all up into excursions. Then we separated that out into 5 different sections for each of the 5 nodes in this example. And the way that we're creating the training data from it is we are grabbing 4 items at random, using 3 of those items as the feature, and then 1 item as the label.
I see. Okay. So you get to learn what is associated with other products, essentially.
Exactly. For a collaborative-based recommendation system. So looking at 3 items that one user purchased to find the 4th item as their label. So if you have 3 items in your cart, we're using that as your features and going to map that back up to that user to recommend that 4th.
Very cool.
Yeah. So this is our model control panel, essentially, to where we can create additional models, rename it or duplicate it, train it, and deploy it back out to those child nodes. And then we have this small coding window here to where you can actually create the model. And this is just a simple example of a embedding model. So we have, an embedding layer, and then that goes down into some dense layers, and then back out through just one softmax layer.
Okay, and a quick question at this point. I noticed that this is in JavaScript. Is this JavaScript or Node.js on the back end?
So right now we're running in the browser on JavaScript, and then when it gets deployed and it runs on the nodes in production, that's on Node.js.
Okay, very cool. So basically utilizing both environments. Very nice.
Both environments. TensorFlow.js is quite versatile.
Very cool. Okay, next up.
So this is production monitoring. So this is after we have trained that model on the central node, and it's deployed back down to the child nodes, and then is running production. So they're saving their own production metrics, and that gets published back to the central node. And we can see it here. So for example, the items that the user has already purchased or already has in their cart, the item that we recommend, and whether or not they actually purchased that item.
Nice. I like this kind of real-time nature of it all. That's very, very cool.
It's very nice. It's an evolving process, right? Like you need that pipeline to be smooth and efficient so that way you can keep learning from your model and train it to work better.
Lovely. I'm going to have to try this out next time I go to the supermarket, I think.
Yes. This is for an idea of pretty much you have a tablet that you can attach to a shopping cart that's taking images of what's in the shopping cart. So we get the items that you've already put in there and then recommend an additional one. We named
very
it
cool.
Yes. Yeah. You don't forget.
In fact, maybe that's a good challenge for any of our viewers if they want to make that component of it. They can do the object recognition and then talk to your backend to get a recommendation. If anyone's watching wants to do that, put your answers in the comments.
So we're just showing here how we can use the model control panel to duplicate a model and rename it, so you can keep different versions of it and deploy it back out. And just showing the changes that we would make, for example, adding additional units to a dense layer, then training it, and we can again see the metrics per batch coming through on that graph.
I see. Yeah, and I see you're using a multi-layer perceptron here essentially to do all of this. So the bread and butter of machine learning.
Exactly. Trying to keep it simple to show the potential of what you can do with this.
Yeah. And of course, if users have other models they want to use, they could potentially use anything in their system and use their own training data and so on and so forth too, right?
Certainly. This is just, it's more so to show the DevOps side of it, of how you could train a model and deploy it to multiple nodes. And that model being whatever you wanted to train with, model being whatever you wanted to create, and the data set being whatever you wanted to train with. So this could work on any type of model, on any data set, but this is how you can train it in one location and deploy it out to the edge and get those metrics back really quickly.
So yes, I really love how you can use this as part of your ML stack. And I'm curious why you chose TensorFlow.js for part of this solution.
Well, we've built other recommendation systems with TensorFlow on Python using the TensorFlow recommenders library, which definitely has some power whenever you're dealing with large data sets. But HarperDB runs on Node.js, and so it's very advantageous to have another system that also runs on Node.js. So you're not having to train it with another script and convert it back over, then load it in. It cleans up that pipeline quite a bit, so we can iterate through it quicker. Yeah,
that makes complete sense. We're starting to see a lot of companies actually, for the same reasons as yourself, do this. In fact, LinkedIn now uses us for exactly the same reasons. We've got a Node.js backend, and of course, TensorFlow.js fits right into that stack very nicely versus other potential solutions. Okay, very cool. And if people want to try this out for themselves, how can they do so?
So we have a link at a GitHub repo for this custom function. You can create a free HarperDB instance and then deploy this custom function on there and get up and going.
Excellent. And of course, we'll put the links in the description after the show, so look out for those. And I guess, what are your future plans with this? Do you have any new ideas in mind?
So we are still, this is a collaborative-based method. It would be nice to expand it out to a content-based where we have more information on the individual items, and we can grab features back out and recommend other items based on the features of the items that have been selected. So expanding out there, and also expanding the dashboard to include additional metrics and even the ability to scale other nodes from that dashboard.
Very cool. So I look forward to seeing that. And for our viewers watching, go try HarperDB right now with TensorFlow.js and let us know how you get on in the comments below. And of course, thank you, Kevin, for being on the show.
Thank you, Jason. It's a pleasure to be here.
Thanks to Kevin for that very informative demo. Machine learning can be utilized across the stack, both front-end and back-end, and it's great to see companies like HarperDB embrace both sides of the coin here with their own services to enable super powerful results. Now, I think this is a trend we're going to see continue to grow over the coming years, which of course is a great win for the community, and even more companies start looking for folk with WebML skills higher in the future too. Now, with that grand finale, thank you everyone, and to our amazing presenters today. Feel free to share the recording with friends who could not make it today. It's simply the same YouTube link you're on right now. And for those of you who are still here, we're going to be opening up our private hangout shortly for a chance to ask questions, and of course to win the O'Reilly signed copy book of TensorFlow.js by Gartner Board. Now, a reminder, links to all the demos will be in the description very shortly, so look out for those. And remember to use the hashtag WebML on Twitter or LinkedIn if you make something cool that uses TensorFlow.js to have a chance to be featured at future events just like this show. Thank you everyone for tuning in today. 2022 has been a great year for WebML and TensorFlow.js, and now is the time to get involved. Do take my free edX course if you're looking to get upskilled in this area to produce next generation web apps with superpowers. I'll put the link in the chat and the description. Now, we'll be seeing you all in 3 months with even more great demos, so look out for the next show that'll be hosted by my new co-host, Jen Person, who's in the live chat right now. And of course, do subscribe and hit like so you don't miss it. Okay, so now it's time for our private hangout for those of you who wish to meet in a non-recorded setting to nerd out with fellow community members, and maybe even the presenters if they're still about. Feel free to join using the link I'll put in the live chat very shortly. Thank you so much for watching, and I'll see you next time.